Hi, my name is Archit Mehta, and today we will discuss about the use case about the building of IoT Cloud. So it's something that is built for one of our clients. So I have around 10 years of experience, and I work with companies like EY, Oracle, Walmart, and I work as an independent consultant with US-based startup as well as Indian startups. And this is the recent project that we did for one of our clients, and that is still ongoing. So basically I'll give you the walkthrough about what we did, how we did, what are the challenges, etc. So let's go to the topic for this video. So first is the problem statement, that what are the requirements that client comes to us to solve. Then the application architecture, the cloud architecture, that is basically we are on the AWS. Then what are the upcoming improvements we would have. So the problem statement, basically the client came up with that they need the solution, first of all, something that can run on the cloud as well as on premises. Second is the admin should be able to add the customers, and customers should be able to add the further users. And then it can be basically for each customer we should be able to add the plant. For each plant they have the logger, something that we call the IoT devices, which actually communicate with the server. And each logger can have the devices like inverter, meter, and any kind of devices. And then it can have the any sensors, but we have to track all the sensors in the dashboard. There can be generally inverter have generally 40 sensors. And then basically all the naming should be dynamic. I can change the name anytime, I should be update the name anytime, I can remove the devices, add devices, make it offline anytime. All the things should be configurable. Then it should calculate the amount of, let's say, how much revenue I generated or how many carbon dioxide we save. So that also customer can configure what is their emission rate or what is the energy rate. And the customer should be able to configure the alarm. Okay, for these are the alarm for which I need the alert over the email. And then there are few other requirements as well. Now from the dashboard or the chart or monitoring perspective, what the customer wanted, that we should have the metrics, that is for the plant's power, energy, revenue, emission. That should be like for the total plant, as well as basically if the customer has a 4 plant, it should have the total of all as well as the for each individual plant. Then what is the daily energy generation that is happening for a monthly basis. Then the line chart to analyze the voltage, current, frequency for any devices for particular time period. Then similarly the analysis chart, so that is like if I want to compare for the devices like inverter 1 and inverter 2, what is the thing like comparing between the voltage versus the current, and for x time to y time, then I should be able to actually get it, and I should able to get the report, also able to should download the report for that. So and then the showing the alarm, basically the live alarm, whenever it raise, it should be there onto the dashboard. So those are the very high level requirements that come. So I'll now basically give you a walkthrough about the architecture. So what we have is basically right now, so basically devices, actually we are using the InfluxDB for the capturing all the time series data of the sensors. So there are two ways we does it, that I'll explain it when I'll show the diagram. And for the metadata, all the asset and the client and customers, role-based access control, authentication, username, password, we are using the Postgres. For the caching we are using the Redis. Backend is built into Java and Spring Boot, and the front end is the React.js, and that is based on the Material UI. If I give you walkthrough of the application architecture, so basically we have the user here, and we'll have basically it will have the dashboard queries. One service we have is the dashboard service. Basically everything that you see in the dashboard, that would come from this services. Second is the write API service. So generally currently what happening is most of the sensors, that hardware actually directly write to the InfluxDB, but there are few things like I want to measure the energy and I want to measure the revenue, but the revenue is something that can change. Today is, let the energy rate is 6 rupees, tomorrow it can change to 7 rupees. And same for the CO2 emission rate, if today is 8.1, tomorrow it can become 8.15. So whenever we send the request, actually we want to calculate it pre-hand and then store it, so that whenever we want to retry, we don't have to do any calculation, we just do an influx query and we can get this value. So those two things we are actually writing is to the basically this service. And then all other sensors like the temperature and inverter, voltage, current, everything is going directly to influx database. Then we have the Redis cache. So whatever we can actually, we try to do cache as much as we can. So what, like the configuration, metadata, other thing does not change, so we simply cache it. Now the dashboard is basically a Spring Boot application, web application, which have all the APIs. So whatever basically we log in, log out, the customer does queries for various things, for the various graphs, and he want to configure the add the asset and all the admin metadata configuration, etc. So all that we have into the SQL database. We have the complete mapping of it. And then we here also basically whenever application start, it actually take the read from the database and cache almost everything. We are doing the caching because those metadata is something that rarely changes. Then we have here one thing called the service communication. So this is actually used that for example, what if the right API, let's say maybe a rate change from 5 rupees to 7 rupees. So that query would actually come to the dashboard. It would be in the database and the cache, but the right API service would not know that somebody has actually changed the price. So in those cases, the dashboard service can actually push to the right API service. So whenever the new request come, it actually start taking the new values. So this is how the overall architecture is. Now basically if we go to the next, so next is about the cloud architecture. So we are using the AWS, everything is on the Kubernetes and the Docker. So we have the network load balancer, elastic container, secret manager, certificate manager, route 53 and the S3. So UI basically as of now we have deployed on the S3 and network load balancer, so that we can actually do a public, it can give the public IP. And the thing is, one more thing is, in future we currently the hardware is actually sending the InfluxDB using the HTTPS, but in future we may want the MQTT integration. So that's why the network load balancer can help in that. So that is the overall AWS architecture. So if I just give you that walkthrough here. So here basically we have the AWS cloud, then we have the region, and then we have our virtual public cloud. So the services that we have, that is basically the AWS S3, CloudWatch, IAM role, secret manager and certificate manager. So that is there. This thing is actually out of the VPC. This one I have to correct the graph. But here if you look, here we have the user, here we have hardware, and then there is the influx database, that is we are using the influx cloud 2.0. Now the request come to the network load balancer. Here we have the availability zone for the ingress things, for the Nginx ingress, so that we can do an entry. The EKS cluster is basically inside the private subnet. The complete EKS would remain there. So this Nginx is basically the ingress through which it can actually route the traffic to the specific service, basically into the cluster. And then here we have the dashboard and the right API service. And this Nginx is basically this is not the ingress, the Nginx. This is basically one that actually see the request, and based on that it is required, okay, if it is a dashboard request, redirect it there. If it is a right API request, redirect it there. So this management is done by that services. And then we have the RDS database that is into again the private subnet. So this is the overall basically very high level architecture of the AWS. Now we will actually give you the walkthrough of the dashboard features that we have. So here we have the dashboard, the home page. So currently if you see, we can have actually the plant power, energy, revenue generation, and the CO2 emission. And this is the for the complete March data from 1 to 31st, that how much actually energy we generated. Here there is now as of now there is no live end, so we don't see it here. And here I have actually select the demo 1 or demo 2 plant, and based on that this graph actually would reflect those changes. Now I go to the monitoring part. So in the monitoring, basically what we have is we call something the measurement chart. So default it will actually show the active power, and it will show for the demo 1 asset is basically the plant. So for the demo 1 plant, we have the 4 devices, and if you see here, currently each device actually have the same data, it is capturing the same measurement. So that's why the values are same. But if you go here, if I highlight here, it will show that one. and here is the time, that what is the again that timeline, it is how it is behaving. I can actually change the inverters to the KPIs, or I can change the sensors. Basically, if I select the inverter here, I can have the sensors here, and based on the sensor I can select the date and apply. The graph would actually shows this thing. So overall the meaning of this graph is we can select the day, and for the particular dates data you can actually show that how that particular sensor has behaved and what is their data. And the same thing is captured here, so I can actually download it as Excel or the CSV here. Now I go to the basically alarm page. So in case of alarm page, it is same. I can actually choose the plant and then choose the devices for which I want to see the alarms, or I can basically choose any combination of it and select the timeline and apply, and it will show that okay, in this case currently the device 1 has generated this many alarms, and we can again download the report here. If we can have the device category, either you put it or you can skip it. Severity also you can have the skip it or you can put it. Similarly, all kind of combinations are possible here. And here is the UI component where we can actually do the all kind of filters that we want to do, all kind of filter that we basically can perform on the data grid. Those options are also available. Then the main feature that will go through, and probably the most complex feature, and that is basically I want to compare for any of the devices. I can select as many as devices for particular plant, and I want to show the graph that how it behaves against like the voltage against the current, or against the temperature, or against the basically anything. Basically here in the y1 graph you can select basically anything out of this, and similarly for the y2 you can select anything out of it. And then you can select, okay, you want to select voltage phase 1 2 3. This is also the multi select. You can select as many as you want. So here you can select the voltage, and here you can select the current, and then you can actually analyze how it is behaving. So in this example, the one that I am showing, I have selected the inverter 1 and 2, and I want to see the voltage on the y1 and the current on the y2 axis. And this is the graph what it shows, basically how the behavior of the current changes according to the change in the voltage. And the same is actually shown here, and here also you can actually download the report in terms of the CSV or Excel. So this is the overall feature that we have built, and there are a few other things that we're going to do next. So if I give you the walkthrough for those parts, are basically we will have the billing improvement. So basically for each customer we need to know how much API they have used, and based on that we can actually do a charge to them. So that is the one feature. Second is the role based access control. So currently it is there, but what we want in the future is that if a customer has a 10 user, he can actually create a role like, okay, east zone plant or west zone plant. He can put his plant 1 2 3 into the west zone, and user 1 2 3 will have only access to monitor the plant who are into the west zone. User 4 5 6 may have only access to the plant into the east zone. Some other user, maybe a number 9, will have access to both the east and west plant. So something like that is something we need to do. Second is we have to work on the hardware update. So basically how we can do the OT upgrade, how we can do the basically certificate based authentication, so that it actually we know the traffic that reach to the server is properly. And then the MQTT based communication. So right now, as I told earlier that from the hardware everything goes through the InfluxDB, and that is using the HTTPS, but that is not highly scalable approach when we have the like thousands and thousands of devices and pushing the data every second. So in this case we have to move to the MQTT and the Kafka based communication with the server. So that is something that we are going to do next. So that's it for the presentation. Thank you very much. And in case like if you have any doubt or you need some help on this part of things, feel free to reach out to me. My communication details are here. So that's it for this presentation, and thank you everyone. Enjoy your day.